Okay, so one of the biggest parts of the syllabus is data. And data is made up of a whole load of different topics, but where I want to start is the averages and range. And so first we need to know the difference between level 1 and level 2. At level 1, if you've taken level 1, you'll know that we deal with the mean and we deal with the range. At level 2, we add some new things to the mix. We have the mean, we have the median, we have the mode, and we have the range. So these two are the same, but these two are new at level 2 that you might not have seen before at level 1. So first of all, we want to speak about, well, what are all of these different things? We'll go through each of them in turn, giving you practice at each one before we move on to the next one. So let's start with the mean. What is the mean? Well, the mean is, with all averages, trying to get towards some sort of sensible middle point for our data. And so the method for doing the mean is add up all the figures, divide by how many figures there are. So just as a quick example, if I've got 1, 3, 4, 5 and 5, I'm going to add up all of these numbers. So it's 14, 17, 18. And then my sum would be 18 divided by 5, which is going to be 3.6, I believe. Yes, so my average would be 3.6. And that would be my mean average for this set of data. And so that's how we work out what the mean will be. So here's an example question. I've got some data and we're going to use the same set of data for each of the three averages to show you how they are different from one another. So in this example, I'm going to add up all 10 numbers. And so on my calculator, if you aren't given a calculator, you can do this in your head, but just to save time, we're going to add all the numbers up together. Like so. And get 80. And if we get 80, we divide it by 10. What we'd end up as our method is 80 divided by 10 equals 8. And so the mean for this set of data is 8. And that's a general principle for how mean is going to work. You add up all the numbers, divide by how many numbers there are. So here's an example question for the mean. They say an employer makes a change to how people work in order to see if it will reduce the average amount of time employers take off of work. Have the changes improved the situation? So have a think, have a go, and I'll be back in 5 seconds to go through it with you. Okay, so we have 4 employees. So we know that our answer is going to be divided by 4. And that's for both of these. First of all, I'm going to add up my numbers, 5, 7, 11, and 23. So let's do before changes first. I'll make my text red so you can see it. Before is going to be 5 plus 2 plus 4 plus 12 equals 23. And then divided by 4 is going to be 5 and a bit, 5.75. So it's going to be equal to 5.75 days on average that people were sick through the year. Now, if we do the after, same principle, we do after. I'll change this to red in a second. We're going to have 3 plus 4 plus 5 plus 10, which is going to be 22. Divided by 4 equals 5.5 days. And so the language they use is quite important. If they're saying have they improved the situation, we're assuming that they want to have less people off of work. The average has gone down to 5.5 days. And so we would say that yes, the situation has improved. Only slightly, it hasn't made a massive amount of difference, but it has improved the situation because we've gone down to 5.5 days instead of 5.75 days. And that would be my answer for that. So very good job if you managed to get that. If you didn't, don't worry, go back, have a look through the mean again, try and figure out how we get to that. But most people would be okay with this because it's level 1 and we're moving it up to level 2. Though you may not have done level 1, so this might be new to you. Okay. Moving on to the median. But what is the median? We know that all averages are trying to find the middle, but the median is the exact middle. So we have the exact middle. Here's the median. And how do we find the exact middle? Well, what we have to do is line up our numbers in order of size. It doesn't matter if it's smallest to biggest or biggest to smallest. Whatever you want to do is up to you. Cross off numbers from each end until we reach the middle. And if there's only one middle number, that will be our answer. But if there's two middle numbers, add them up and divide by 2. And so that is our notes for how we do the median. If we have two middle numbers, so we've crossed off, and we're left with 2, meaning if we cross them both off, we'd have nothing left. We add them up, divide it by 2, and that will be our answer for the median. So going back to my 10 numbers that I've written before, we see that there are here, but they're not in any sort of order. So in my red pen, I'm going to order them in terms of size. So we've got 3, then 4, then 5, then 5, then 6, then 7, then 9, then 11, then 14, then 16, and counting to make sure you have got 10 numbers, and I have. And so what I'm going to end up with is a set of numbers in order that I'm going to cross off one by one from each end towards the middle. And what I end up with is 2 numbers in the middle. If I cross both these off, I'll have nothing left. So at this point, I'm going to add them both together. So 6 add 7 equals 13. And then 13 divided by 2 equals 6.5. Or exactly halfway between 6 and 7. So in this case, the median of my data is 6.5 or 6.5. And that would be the median for this data. Okay, I'm going to come back to this set of data in a minute. But for now, here's a practice question on the median. A manager in a company wishes to know which employees currently earn less than the median salary. We must tick all the employees who earn less than the median salary. So we have a list of surnames, the staff members, and their wage in thousands. And so we're going to work out the median and who has less and tick them off. So have a go at this, and I will see you in just a second. Okay, so first things first, we know with the median we're going to have to order all of our numbers. So there's lots of different systems to work out how to do this, but what I tend to do is look down my list, find the smallest number, which is 14, make a note of it, and then write it down. So that's 14. Keep going along with this, so it's going to be 15, then 16, then 17, then 18, then 2 19s, and a 25, because there are 1, 2, 3, 4, 8 things, and I've got 8 numbers. So we know then that the median salary is going to be in the middle of these 2 numbers when I cross them off, but of course always do the method. So I'm going to cross them off as I go down, 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 across, across, across. I'm going to end up with 2. That means my median is going to be 17.5. So all employees that earn less than 17,500 are going to be the median, less than the median. So I tick this person, I tick this person, I tick this person, and I tick this person. So you can even put dashes across if you're worried about being a little bit confusing. And so that's what we're going to have. These are the 4 people that earn less than the median salary. And you might be able to just see that, but if you're not sure, put them in order, cross them off, we'll get a middle number, and we can work out the employees who earn less than the median. So good job you managed to get that. Median throws a lot of people off. The key thing to remember is they have to go in order of size for it to work. Otherwise, you don't get a proper middle number. Okay, next, the mode. Well, what is the mode? The mode is the most occurring number. So what that means is the number that appears the most times. So in this case, if we have some data, I have 1, 3, 3, 4, and 5. We would say that the most occurring number is 3 because there are 2 3s. And so our mode is the number 3. However, sometimes there won't be a mode. And so we can say there isn't always a mode. And by that I mean, take this set of numbers, for example, I'm going to do here. 1, 3, 3, 5, 5, 9, 10, 10, 12, 13, 15, and 15. Okay? So I've put them in an order for you. Putting them in order also helps with the mode, just so you can keep all the numbers grouped together. If we see here, we have 2 3s, but 2 5s, and 2 10s, and 2 15s. So there isn't a specific number that appears the most times. There's 4 different numbers that all appear the same amount of times. And so in this case, what we would say is no mode, or mode isn't useful, because it doesn't tell us anything. One of our modes is right at the top of the data, and one of our modes is right at the bottom of the data, so it doesn't really help us very much. We could argue if, say, both the 3 and the 5 are the only modes, that's at least in the same ballpark, but because they're all over the data and there's 4 different modes with 2 numbers each, we would say in this case there is no modal value. Mode isn't useful. So you might see the word modal. That means mode. So if you see the word modal, that means the mode. So if you see that in an exam paper, that's what we're talking about. Okay, going back to my same numbers again. What is the mode of this data? Well, I could put them in order, or I could see that there are 2 5s and no other numbers that match the same. So in this case, the mode is 5. And so if you're ever unsure, put them in order, the same as the median, and then we can work out how many appear next to each other. And so we've got 5 as our mode for this data. So here is a practice for the mode. I've scrambled all the numbers up. Calculate the mode of the following data and give a reason for your answer. So I'll see you in a second. Have a go. Okay, and so when we put our numbers in order, what we find is we have this sequence of numbers. And what we get is that there are 3 2s and there are 3 4s. And so what we would say in this case is no mode more than one number appears the most times. So I've been a little bit cheeky there. Just as an example, if there was only one more 2 or one more 4, then that would be the mode. But because there are 2 numbers that share the same, it's not that useful for us. They're in the same ballpark of the data, so we could say that the mode is more close to the start than it is to the end. My hands might be going in the wrong directions. But in this case, because not one single number appears the most times, we would say that there's no mode, or at least it isn't very useful as an average to use for this data. And so that's that. Good job if you caught on to my little trick. If not, then just be aware that sometimes they will ask you a question about a mode where there isn't a mode, and you just need to say that it's not very useful because XYZ reasons. Okay, moving on to this topic. This isn't really work, it's more about a discussion really. Why do we choose one average over another? Let's consider this data here. Okay, there are 10 numbers, and so if we were going to work out the mean, we would of course add them all up and divide by how many there are, which in this case I've done for you is going to be 12.2. But I'll show you how I did it, just to check again. 5 plus 5 plus 100 plus 3 plus 2 plus 1 plus 1 plus 1 is 122, divided by 10 is 12.2. So my mean is going to be 122 divided by 10 is equal to 12.2. Is that the most useful piece of data to work out the average of this group? Well, not really. If we consider the actual size of the numbers, most of these numbers are single digits, but our average is 12.2. But what's happened there? What's happened is that this 100 has distorted the data. What we call that is an outlier, a data point that doesn't really fit within all of the rest of the set of data. And so what we'd say is that the mean, one of the problems we have with the mean, is the mean can be distorted by high or low numbers. I'll go and put the word very in here because very high or low numbers. So very high or low numbers, so like this 100, is essentially drawn the mean way up here when it's supposed to be more down here. And so the mean can be distorted by very high or very low numbers. And so that's why we don't like it that much at level 2 when there is a wide range of numbers. We'll get to the range in a second, but when the range of numbers is very high, we don't like to use the mean. What we could do is we could remove this 100 and say, okay, let me just discount it. I know it's too big, I know it's going to distort the data. So what happens then is if we do a revised mean, we've changed it, what we're going to have is 22 over 9 instead. Because I've got rid of the 100, so that's 22, and there's one less number, so it's 22 divided by 9 now. And so that's 2.444. So 2.44. That seems more reasonable for my mean, because the biggest number is 5 and the smallest number is 1, so we'd expect it to be somewhere between 1 and 5. And so we've got our middle number, as 2.44, that seems fairly reasonable. And so with revised mean, we've essentially discounted the outlier. And we can do that, or we can use a different average altogether. So let's stick with our mean number as 12.2, but let's use the median instead. So what I'm going to do is I'm going to reorder my numbers into order. I've got 4 ones, I've got 2, then 3, then 3, then 5, then 5, then 100. And so I've still got 10 numbers. I now cross off my numbers one by one. 1, 2, 3, 4, 5, 6, 7, and 8, because there's 2 numbers left. If I add these up and half it, I'm going to get median is equal to 2 plus 3 equals 5, divided by 2 equals 2.5. So what I've got is 2.5. So that's much closer to my revised mean, which is 2.44. But also what the median is good for is the median is not affected by very high or very low numbers. It doesn't care at all about the size of the numbers, because it's going to get put at the end anyway and then discounted as we cut down towards the middle. And so the median is not affected. So if they ever ask you a question as to why you might choose one average over the other, you can say that the median is a good choice because it doesn't get affected by big or small numbers. One of the downsides of the median, of course, is that it takes longer to do because you've got to order all of your numbers. And so if you've got a lot of numbers, it will take a longer time to organize them into a reasonable order. And so, yes, we could also do the mode just for fun. We would say that the mode in this case would be 1 because there's 4 ones. Again, in this case, the mode is not the most useful average because we know that from the other 2 averages, it's going to be somewhere between 2 and 3, but our mode is right down at 1. So it's kind of the opposite problem. We know that 1 happened the most times, but unless that's contextually useful to us, we're not going to use that as a reasonable average. That might be useful. The mode can be useful in places like sales in a shop. So how much of a certain brand sells more, they would know to stock more of that brand in the shop because people are buying it the most. That kind of thing is where mode is more useful. But in general data, mode isn't the most useful average of all. Okay, so going on to the range then. Well, what is the range? The range is the difference between the highest and smallest number. So whenever you've got a data set, we've got the biggest and smallest number. The difference between the two is going to be my range. There we go. I actually changed it to black now. There we go. So the difference between the highest and smallest number. So just out of instance, if I've got 1, 3, then 10, then 12. Yeah. Then what we're going to have is the difference between 12 and 1 is 11. Because 12 is the highest and 1 is the smallest. So we tend to do biggest take away smallest because you can't have a negative range. Similar to you can't have a negative difference. You're always going to have a positive difference no matter what you do. In terms of when we're talking about things like a shape's length or bits of data, a difference is always going to be a positive number rather than a negative one. Okay, so moving on to my same data set again. In this case, my range is the difference between 16, which is my biggest number, and 3, which is my smallest number. And so the range is going to be 16 take away 3 is 13. And that's the range. This is level 1 stuff, so hopefully the range is not too confusing a concept. It's just about working out the difference between the two things. Where it gets a bit more tricky at level 2 and level 1 is when they want you to make comments about the averages and the range. So when we're talking about the range comments we can make are about consistency. And so the word consistency might be seen, or data is more or less consistent. And what that actually means is how predictable the data is. How predictable the data is. So, for example, if we have a low range, that means it's very consistent, which means it's predictable. For example, if you run a bakery and the difference between the highest amount of sales you make in a week and the lowest amount of sales you make in a week is very small, that means that we can predict how much we're going to sell every week. So how much bread do we need to buy, how much flour, how much sugar, how much all of these things, because we can predict how many sales we're actually going to be making. Whereas a high range is going to be very inconsistent and not predictable. And that's generally seen as a bad thing. So I'm going to make it a bit smaller so it all fits on one line, as I tend to do. There we go. So that would be an example of, say you're running, which is a question coming up about this, but if we're running in a 200 meter race or 400 meter race, and our times are very inconsistent, what that means is from one run to the next, I can't really predict how fast I'm going to be able to do the run. Which is a problem because it means that I can't really gauge whether I'm improving or not because my time's up and down like a yo-yo. And so the key takeaway from this is low range is good consistency, which is predictable. High range is bad consistency or inconsistency, and that means it's not predictable. And so lower the range, the better it is generally. Okay, here we go on a practice of my range. So this is some times that a person has done when they're training, I don't know, some kind of run. And we've got to compare the range of time before training and after training. And if training has improved the times, how much so, and what could we say about it? So have a go at this, and I'll be back in just a second. Okay, so this one is a little bit tricky because it's thrown in some time as well, and often in functional skills they will throw in 2 or 3 different topics within one question. And so this question is all about time. So the first thing I'm going to do is I'm going to change all of my times to seconds because then I can compare them like for like. So I'm going to say this is 63 seconds, this is 95 seconds, this is 121 seconds, and this is 124 seconds. Changing it here, this is going to be 75 seconds, this is going to be 84 seconds, this is going to be 112 seconds, and this is going to be 95 seconds. Okay, so now we've got our differences in times. So what we do is we take our biggest time and take away our smallest time. So we've got 124, take away 63 is going to be equal to 61 seconds. And after training, it was 112, take away 75, which is going to be a difference of 37 seconds. And so we can see here that our training has made a big difference to our consistency because we are not only more consistent, but it's more predictable. It doesn't mean that we're always faster. For example, here on attempt 1, we were actually slower than we were before. But on average, we've actually improved our consistency of times. They are more consistent. And we could say, if training has improved the time, how much so? We would work out the difference between these. Improved range by 24 seconds. Our range is 24 seconds smaller than it was before. And so that's what we could say about that. That would be an example of how range is used in a question. And we want to usually mention the words consistency and average and stuff. If they ask for a comment, we're going to say his running is now more consistent because his range is smaller. And that's what we'll say about that. So very good job if you managed to get that right. If not, the problem is time. We want to convert them all to seconds just because trying to do it in minutes and seconds in your head might get a bit confusing because it's not 100 seconds in a minute, it's 60 seconds in a minute. And so we have to work out how to go back from there. So I'd put them in seconds first and then compare them. Okay, so here is an example of a exam style question that would be asked about all 3 averages. You could get asked about mean, median, or mode, or range, and often you'll have to make a comment about the average as well. And so here it says, John and Lava compete in a fishing competition. The winner is decided by the size of the average fish both have caught. John says, because I've caught more fish, I must have won the competition. So decide whether John is correct or not using evidence to validate your decision. So have a go at this, and I will be back in a minute to see how you get on. Okay, so what we have here is a averages question, and the word average means we can pick any one we want, though in this case we're probably going to pick the mean because the median and the mode aren't really going to help us. The mode because there are no numbers that repeat in any of these, and the median because they both aren't the same length of set. So this has 7 numbers in it, but this only has 3. So the median is not that useful either. So in this case, we're going to have the mean as what we're going to choose. So let's do John first. We're going to add up all of our numbers. And I'll change this to red in a second so you can see what my writing is and what the question is. Okay, so that's going to be all of my numbers. Helps to actually change it to red. There we go. There we are. So I'm going to add this into my calculator. Move that a second. There we go. Put this in my calculator like this. Press equals, and that's going to be equal to 61. So we've got 61 divided by the amount of fish that he's caught, which is 7. And so 61 divided by 7 is 8.71. Let's do it to 2 decimal places. 8.71 kilograms. These are both in kilograms. It doesn't matter what the units of measurement are, but let's say they're in kilograms. So it's going to be 8.71 kilograms. Then for Lara, we're going to say that she has 15.4, add 16.2, add 13.2. And so that is going to be equal to 44.8. And so what we've got is 44.8 divided by 3 to work out the average size of her fish, which is 14.93. And so we can see that clearly John is not correct. Yes, he has caught more fish, but not only are all of his fish smaller than any of the fish that Lara have caught, but there are more of them. So when we find the average size of the fish, it actually hinders him that he's caught so many small fish compared to some bigger fish. And so what we end up saying is, no, John is incorrect. And you could even say that on average, Lara's fish are 4.22 kilograms, no, 6.22, sorry, kilograms larger than John's, or something like that. But this would basically be enough evidence to say, no, he's incorrect. So when you get a question like this, make sure you answer at the end by saying, no, he is incorrect, because Lara's average fish size is 6.22 kilograms larger, or something like that. That kind of language will do. Yes, and so that is an example of an exam question that came up. This was in a AQA paper, and so that's an example of the kind of question they will ask you. And very good job if you managed to get that right. And that is really, until we get to the especially level 2 stuff, which will be in another video, that's all the averages stuff you need to know at level 2. So I will see you in just a second for the next video, where we talk about the grouped mean and further data stuff that you need to know specifically at level 2. Thanks for watching.